Hello students, today we'll be taking the first chapter from the book, that is some basic concepts of chemistry, and we'll be starting from the very beginning, that is from the atomic mass. Okay, as the name suggests, atomic mass means the mass of an atom. Okay, and you know that atoms are very tiny species. Okay, they are the smallest particle which make up matter. Yes, and you know that atoms, it cannot be seen with the naked eye. Yes, even with very powerful microscope, it is not possible to see such tiny atoms. Okay, and to measure the mass of these tiny species, it's not possible. Okay, like for example, we can measure the mass of potatoes. Yes, like whether it is 1 kg, 2 kg, half kg. With the help of common balance, we measure. Okay, we cannot do the same thing for atomic mass. Okay, we cannot measure the mass of these tiny particles, atoms. Okay, practically. Okay, so even if you calculate the atomic mass by indirect method, okay, it comes out to be in the order of 10 to the power minus 34 grams, very small. Okay, or 10 to the power minus 33 grams, very tiny. Yes, the mass is very less, and to use such like numbers for calculation, it is not convenient. Yes, to use these kind of numbers. So what we do is, instead of calculating the actual mass of an atom, what we use is relative atomic mass. Okay, relative atomic mass means atomic mass in relation with some other standard element. Okay, with some other standard element. So the standard element that we are taking is this one, carbon. Okay, carbon atom. Standard element is carbon atom, and carbon also has got 3 isotopes. So which isotope we are taking? 12C isotope of carbon atom. Okay, so you can see here relative atomic mass of an element, any element like oxygen, nitrogen, hydrogen, would be the number of times one atom of the element is heavier than 1/12th portion of 12C isotope of carbon atom. Now let's see what is this one. 1/12th portion of 12C. Suppose this is carbon atom. Okay, which carbon atom? Isotope 12. Okay, one atom. Let's divide it into 12 parts. 2, 4 parts, 5, 6, 7, 8, 9, 10, 11, 12. 12 parts we divided. Out of these, okay, just one part here, I'm shading it. This is, 1/12th part. Yes, 1/12th part of this carbon atom. Okay, so relative atomic mass would be how much that atom of the element is heavier than this part, 1/12th part of carbon atom. Meaning, suppose, example, you know that oxygen atom. Okay, oxygen atom atomic mass of oxygen atom is, you know that it is 16. Yes, it means that our oxygen atom is 16 times heavier than this portion. What is this portion? 1/12th part of 12C isotope of carbon. Okay, so as you can see, this atomic mass is in relation with some standard element, this one, carbon element. Okay, atom of carbon. Right, so this is relative atomic mass. And another one is, that relative atomic mass of, let's take another one, nitrogen. Nitrogen, okay, it is how much? 14. It means that our nitrogen atom is 14 times heavier than this one. Okay, 1/12th portion of 12C isotope of carbon. Okay, so that is the meaning of relative atomic mass. Okay, it is not the actual mass. It is the mass in relation with some other atom. Which atom? 12C isotope of carbon atom. Okay, the next one we have got gram atomic mass. Simple thing out here, to relative atomic mass, if you express that in grams, that is gram atomic mass. Okay, like for example out here, Relative atomic mass of oxygen is 16. Gram atomic mass is, you just add 6 grams out here. That is 16 grams. Okay, out here for nitrogen, relative atomic mass is 14. So gram atomic mass would be 14 grams. Okay. Then next one, molecular mass. Okay, molecular mass means the mass of the molecule. Like for example, which molecule? Okay, nitrogen molecule, N2. Oxygen molecule, O2. Carbon dioxide, CO2. Mass of these. Okay, again molecules are small species. Okay, very tiny particles. So here also what we use, the same thing, relative molecular mass. Okay, so as you can see here, where is it? Relative molecular mass of an element or a compound is the number of times a molecule of the substance is heavier than 12C, 1 by 12th of the mass of carbon atom. Same thing for molecule also. Okay, and gram molecular mass expressed in grams, gram molecular mass. And you know very well molecular mass. How do you find out? We find out the molecular mass by adding up the atomic masses. Yes. Like for example, N2 is there. Okay, N2, nitrogen, how many are there? 2. What is the atomic mass of nitrogen? 14 into 2, 28 grams. Like for example, carbon dioxide, atomic mass of carbon is 12, oxygen is 16, 16 into 2, 12 plus 16 into 2. Okay, 12 plus 6 2s are 12, 2 1s 2, 32. 44. Yes, this is how we find out the molecular mass. Okay. Then unit, you know, the atomic mass and molecular mass are expressed in AMU, atomic mass unit. And what is atomic mass unit? Atomic mass, one atomic mass unit is 1/12 of the mass of one carbon of 12C. Okay, so mass of this one, mass of 1 by 12 portion of 12C carbon is AMU, atomic mass unit. Okay, then after that, find out the molecular mass of CaCO3. Okay, I have done for CaCO3, calcium carbonate. Calcium, you know, atomic mass is 40, carbon is 12, oxygen is 16. So, you know how to do this, no? CaCO3, C12 carbon, oxygen 16 into 3, we get 100 AMU. Okay, then there is here H2SO4 and CO2. Do it by yourself. Okay, hydrogen is 1, you know that. Atomic mass of hydrogen is 1. Sulfur is 32, oxygen is 16. Okay, so please find out for this one. And carbon dioxide. Okay. Then next we have got the mole concept. You have done a little bit of this in class 10 also. Yes, so you know very well the mole. Okay, mole, 1 mole means a collection of particles. Okay, like for example, 1 dozen means 12 particles. Yes or no? Okay, anything 12 is 1 dozen. Similarly, 1 mole would be how many particles? The Avogadro number. This one, you know, it is 6.023 into 10 to the power 23 particles. That is Avogadro number of particles. Okay, and this 1 mole can be 1 mole of atoms or it can be 1 mole of molecules. Okay, 1 mole of atoms means 6.023 into 10 to the power 23 number of atoms. 1 mole of molecules means 6.023 into 10 to the power 23 number of molecules. Okay, then 1 mole of atoms, okay, the weight of 1 mole of atoms would be its gram atomic mass. Okay, gram atomic mass, we did earlier, no? It's written out here, 1 mole of oxygen atoms. 1 mole of oxygen atoms, meaning this number of oxygen atoms would be equal to, the weight would be equal to gram atomic mass of oxygen, you know it is 16 grams. Okay, and 1 mole of molecules, 1 mole of molecules, the weight would be equal to gram molecular mass. So 1 mole of molecules, O2 molecules, what is the weight? 16 into 2, 32 grams. This is a gram molecular mass. Okay. Then 1 mole of any gas. Okay, now let's compare it with the volume. Relation of mole with volume here. Okay, volume of 1 mole of molecules. 1 mole of any molecule. Okay, like for oxygen, carbon dioxide. Okay, whatever it is, always will have a fixed volume. Okay, fixed volume. Volume means the space occupied. Yes, it is 22.4 liters. Okay, or in terms of milliliter, it would be 22,400 milliliter. I hope you know this. Yes or no? Relation of mole with volume. Remember, 1 mole of molecule always has got a fixed volume, that is 22.4 liters. And 1 mole means how many particles? This one, Avogadro number of particles. 1 mole of the molecules, the weight would be gram molecular mass. Okay, mole and weight relation, mole with volume relation. Okay, remember that. And so I have written out here, I've taken the example of nitrogen. 1 mole of N2. 1 mole of N2 means what? 1 mole of nitrogen molecule. Okay, molecules means how many particles will be there? Avogadro number of molecules. Yes, and the weight of this would be the molecular mass. Gram molecular mass of nitrogen is how much? N2 equals to 14 for nitrogen into 2. 14 into 2, 28 grams. And what is the volume of 1 mole? Always 22.4 liters. Okay, at STP. You know, this is at STP, standard temperature and pressure. Okay, or you can also write it as NTP, normal temperature and pressure. Okay, now next I've given you a small here relation to find out the number of moles. Okay, so number of moles, you can find it out with this relation, equals to given weight by the molecular weight. Okay, number of moles given weight by molecular weight. Let's take an example. Suppose you have got a question. Find out the number of moles. You are asked to find out the number of moles of oxygen. Okay, O2 molecule. And you are given how much O2 gas? 64 grams. Weight is given 64 grams. Okay, so you are asked to find out the number of moles. So you know the relation, number of moles given weight by molecular weight. Given weight is how much here? Weight given is 64. So 64 divided by the molecular weight of oxygen, you know. O2 equals to 16 into 2. 16 is the atomic mass for oxygen. Okay, 16 into 2, 32. So you got 2 moles. Okay, so you can use this relation. Number of moles, the weight given divided by the molecular weight. Okay, and another thing in chemistry, weight and mass is same. Okay, mass and weight, they are same. If you write molecular weight here, it also means molecular mass, but physics it's not so. Okay, mass and weight are different in physics. Okay, now using the mole concept, we'll solve some questions. Okay, so the first question out here is, how many gram molecules and how many grams of ammonia? Ammonia, you know, it is NH3. Yes, are present in 100 liters of ammonia at STP. At standard temperature and pressure, you are given 100 liters of ammonia. 100 liters means what? It is given volume. Volume of ammonia is given 100 liters. Okay, then what we have to find out is how many gram molecules. Now, gram molecules means how many moles. Okay, how many moles. And how many grams means what? How many grams means weight. You have to find out the moles and weight, and you are given volume. Okay, let's try to see. Let's find out the first one. How many gram molecules are the moles? Okay, what we are given is volume. We have to find out moles. Okay, so whatever we have to find out, we'll keep it on the right hand side here. See, on the right hand side. So we are given volume. Okay, we have to find mole. Okay, how many moles we have to find out? Volume and mole. We are given 100 liters. We have to find out how many moles are there. Okay, so you know very well from the relation moles and volume, always it is 22.4 liters always will contain 1 mole. Yes, volume and mole, what is the relation? 22.4 liters of anything, of any gas, here ammonia, always contains 1 mole. Yes, then unitary method we can follow. 1 liter, if 22.4 liters of ammonia is 1 mole, then 1 liters will be 1 divided by 22.4. For how much we have to find out? 100 liters. So for 100 liters equals to 1 by 22.4 into 100. That gives us 4.64 moles. Okay, in the question, the term uses gram molecules. So we'll use 4.46 gram molecules. Okay. Now next, we got the number of moles. We have to find out the weight. Okay, we have to find out the weight. Alright, now you know very well moles and weight relation. Moles and weight. Here it is molecules, so 1 mole would be gram molecular mass. Yes, so 1 mole of ammonia is equals to gram molecular mass. How much is gram molecular mass? Molecular mass is this one, NH3, nitrogen 14, hydrogen 3 into 1. 3 1 is 3 plus 14, 17 grams. So 1 mole weighs how much? This 17 grams. So we have to find for 4.46 moles weighs 17 into 4.46 equals to 7582 grams. Okay, so this is how we do. Next, let's see another question. Okay, so we have got now a cylinder contains 0.28 grams of ethylene. Okay, now ethylene, you should know that ethylene is ethene. Yes, ethylene is ethene, and ethene formula is C2H4. It's double bonded compound, no? CH2, CH2. Remember, this is ethylene. So we are given 0.8 grams. This is weight. Weight of ethylene is given. You have to find out how many moles of ethylene are there. How many moles? Okay. Now you have to find out how many molecules are there. Atoms of carbon, atoms of hydrogen, electrons are there in it. Okay. So let's see how we do it. So ethylene, you know, it is C2H4. Let's find out the molecular weight first. Okay. Molecular weight or molecular mass. You know how to find out. Carbon is 12 into 2 plus how many hydrogens? 4. So 12 into 2, 24 plus 4, 28. Alright. Multiplication you'll do first, then only addition. Alright, so we get molecular mass is 28 grams. Okay, then the first question was, how many moles are there? You're given the weight. How many moles are there? Okay, simple. You can use this relation. Number of moles equals to given weight. Weight given divided by molecular weight. You can use this, or you can use the unitary method also. Okay, your choice. Okay, unitary method. Unitary method means 1 mole contain how many gram molecular mass? Like that. Okay, you'll do. So we use the formula we have got straight. Number of moles equals to given weight by molecular weight. Given weight is how much? 0.28 grams divided the molecular weight is 28. Okay, so we get 0.01 moles. Fine. Next question is, okay, first one, moles we did. Now we have to find out the number of molecules. Okay. We got the number of moles. You know very well. Moles and molecule relation is this. Yes, 1 mole always contain Avogadro number of molecules. 1 mole contains Avogadro. So for how much we have to find out? 0.1 moles. 0.1 mole equals to 0. This multiply by 0.01. Okay. And 0.01 we can write it as 10 to the power minus 2. Okay, so we get 6.023 into 10 to the power 21 molecules. Yes. The next one, we have to find out how many atoms of carbon are there. Atoms of carbon. Okay, how many atoms of carbon are there? Now, in order to find out the number of atoms for this molecule, okay, we got the number of molecules, yes. Now we have to find out how many atoms are there. Okay, so for 1 molecule, you know, if you take 1 molecule here, how many atoms of carbon are there? 2. 1 molecule means 2 atoms. How many molecules we have to find out for? 6.023 into 21 equals to 2 into this one. Okay, we got 12.046 into 10 to the power 21. So using the scientific notification or scientific notation, okay, we'll get 1.2046 into 10 to the power 22. Okay. Then another question is, how many atoms of hydrogen now? Okay, atoms of hydrogen in one molecule. How many atoms of hydrogen are there? 2 plus 2, 4. So you can find out easily. One molecule, 4 atoms. For how many molecules? 6.023 into 10 to the power 21 equals to 4 into this. Yes. These number of atoms of hydrogen. Okay. Then finally, if you're asked the number of electrons present in it. Okay. Number of electrons. You got the number of molecules. Yes. So first you have to find out how many electrons are there in each molecule. Okay, so let's find out. So ethylene, have a look. How many electrons are there? Carbon, how many electrons will be there? 6. You know that 6 electrons, 6 protons are there in carbon. Hydrogen, how many? 2. Carbon 6, hydrogen 2. 6, 6, 12, 13, 14, 15, 16. So 16 electrons. Okay, so one molecule equals to 16 electrons. So these many molecules, 16 into this. Okay, so we got it. So scientific notation we use and get 9.638 into 10 to the power 22 electrons. So that's how we do. Okay. Then the questions given in the book. Now have a look here. Okay, you'll go through this one here. Example 16. Example 16 here, example 18 here, example 19. Okay, and I want you to do question number 17. It's on page number 1.31. Okay, 17, 18, 19, 21. Okay, do all these. Next we have got percentage composition. Percentage composition of a compound is the percentage by weight of each element present in the compound. It means that percentage composition of a compound. Let's take carbon dioxide. Okay, so percentage composition of carbon dioxide would be the mass percentage or the weight percentage of each of the element. There are 2 elements out here, carbon and oxygen. So mass percentage of carbon present in it and mass percentage or weight percentage of oxygen would be the percentage composition of carbon dioxide. Okay, mass percentage of each of the elements. Okay, now how do we find out the mass percentage? Okay, mass percentage of any element X. Let's take carbon, let's take oxygen. Would be mass of that element in 1 mole compound divided by molar mass of the compound. Molar mass of the total mass of the compound into 100. Okay, so to understand better, let's try an example. So we have got here the question, calculate the mass percentage of different elements present in sodium sulfate. Okay, we are given a compound sodium sulfate. We have to find out the percentage composition. Okay, meaning the mass percentage of each of the element, mass percentage of sodium, mass percentage of sulfur, mass percentage of oxygen. Okay, so for that first we'll find out the molecular mass, okay, of Na2SO4. So sodium, you know, atomic weight is 23. So how many sodium are there? 2. Okay, plus sulfur is 32, just 1 is there. Oxygen is 16, you know that. And how many oxygen are there? 14. So let's calculate. 23, 46, 32 and 64 would be equals to 142. This is the molecular mass. Okay, now let's try and find out the mass percentage of first element, sodium, is equals to mass of sodium in 1 mole. Mass of sodium, how much is the mass of sodium out here? Okay, sodium there are 2, 23 into 2, that is 46. So mass of sodium 46 divided by the total mass is the molecular mass, 142 into 100. Okay, that turns out to be 32.39%. Okay, then mass percentage of the next element, sulfur. Okay, weight of the sulfur divided by the total mass, that is the molecular mass. Weight in the compound is 32 divided by total is 142 into 100, 22.54%. Okay, then finally same for oxygen. Oxygen, how many are there? 16 into 4. Okay, total oxygen present is 16 into 4, 64. So 64 divided by 142 into 100, it would be equal to 45.07%. Okay, so these are the mass percentage percentage of the different elements. Okay, it means that out here 32.39% means in 100 grams of this compound Na2SO4, sodium present is 32.39 grams. The amount of sulfur present is 22.54 grams. Amount of oxygen is 45.07 grams in 100 grams of the compound. Okay, so that is the meaning of mass percentage. Okay, and that's how you find out the percentage composition. Okay, so what you'll do is you'll try few questions. Okay, okay, you can try 34. Okay, out here the compound commonly known as borax, percentage of just one is asked, boron is asked. Okay, you can do this. Okay, then okay, you can do this also. 36. Calculate the percentage of water of crystallization. Okay, you are asked to find out the percentage composition of water of crystallization in the sample blue vitriol. Okay, so here water of crystallization is this one. The extra water molecule is there, no? 5 water molecules are there. So percentage composition of water. Okay, how many water are there? 5. Okay, so out here weight of the water would be 5 into 18. Okay, divided by the molecular mass into 100. That is how you find out. Okay, do this too. Next, let's learn about empirical formula and molecular formula. Okay, molecular formula, we already know what it is. Then there is a new term, empirical formula. Okay, so first let's see molecular formula. The definition would be the formula which gives the actual number of atoms of various elements present in one molecule of the compound. Like for example, molecular formula of carbon dioxide is CO2. Okay, this is the molecular formula of carbon dioxide. The molecular formula tells us about the actual number of different atoms present in it. In carbon dioxide, we have got carbon and oxygen. And in one molecule, one carbon is there and 2 oxygen will be there. Okay, so molecular formula tells us the actual number of different atoms present. Okay, in one molecule of the compound. Then another one is empirical formula. Empirical formula would be the formula which gives the simplest whole number ratio of the atoms of various elements present in one molecule of the compound. Okay, it tells us about the simplest whole number ratio of atoms. Like for example, suppose molecular formula, we write here ethane. Okay, you know ethane. It is to carbon. Okay, so ethane is C2H6. Okay, the molecular formula is ethane is C2H6. It means in one molecule of ethane, 2 carbon are there and 6 hydrogens are there. Okay, now if you want to find out the empirical formula of this, empirical formula, we find out the simplest whole number ratio of the atoms. Okay, here carbon and hydrogen. In the molecular formula, carbon is how much? 2. 2 carbons are there. Hydrogen is 6. Okay, now let's find out the simplest ratio. Okay, simplest ratio, in order to find out, we can divide it by 2. 2 1s are 2. Out here is 2. 2 3s are 6. Okay, this is the simplest one. Yes or no? So empirical formula would be C how many? 1. H how many? 3. Okay, or you can write it as CH3. Okay, so this is the empirical formula. Okay, it's the simplest whole number ratios of atoms of various elements present in it. Similarly, another one, let's take glucose. You know the molecular formula of glucose is C6H12O6. Okay, let's find out the empirical formula. Carbon, hydrogen, oxygen. In the molecular formula, carbon is 6, H212 is to 6. Okay, now let's find out the simplest ratio. Let's find out the simplest ratio for this one. We can divide it by 2 first. Yes, 2 3s are 6, or 2 6 are 12, 2 3s are 6. Again we can divide. 3 1s are 3, 3 2s are 6, 3 1s are 3. Okay, 3 1s are 3. So what we got out here is the simplest ratio is this one. 1 is to 2 is to 1. So carbon 1 is to, okay, here hydrogen 2, oxygen 1. So CH2O. This is the empirical formula for glucose. Okay, I hope you got it. It's the formula which gives the simplest whole number ratio. Okay, now as you can see out here, molecular formula of ethane is C2H6 and empirical formula is CH3. Now suppose if I multiply here by 2. Okay, we divided it by 2 out here. No, in order to find the empirical formula. Suppose we divide it by 2. 2 into C1H3 gives you what? Molecular formula. Here, with how much we have to multiply to get the molecular formula? Into 6. If we multiply the empirical formula out here into 6, we get the molecular formula. Yes or no? Okay, so out here in the first case, we have to multiply with 2 for ethane to get the molecular formula from empirical formula. Here we have to multiply it with 6. So 6 and 3 out here can be written as n. Okay, and n can be any integer. 1, 2, 3, 4, 5, 6, like that. Okay, so from this we got one relation, which is molecular formula equals to n into empirical formula. Okay, remember this one, molecular formula, n is any integer, can have the values 1, 2, 3. Okay, like for example, here we have got 2 for ethane. Yes, and here we have got 6 for glucose. Okay, so we see that molecular formula equals to n into empirical formula. Let's bring it out here. Molecular formula by empirical formula equals to n integer, one integer. Okay, then another one. Let's see the molecular mass and the empirical mass. Okay, so here again let's take ethane only. Okay, molecular mass would be here, molecular formula is this one. We can easily find out the molecular mass from the molecular formula. Yes, carbon, it is 12. How many carbon atoms are there? 2 plus 6 into 1. So we got 30. Molecular mass is 30. Then empirical formula mass is, you know, the empirical formula of ethane is CH3. From here we can easily find out the empirical mass. Carbon is 12 and hydrogen is 3. So 12 plus 3 becomes 15. Okay, now also one interesting thing you will notice out here is if you want to relate molecular mass and empirical mass, molecular mass and empirical mass, here also same thing, it will be molecular mass equals to n into empirical mass. Okay, now have a look for ethane. Out here for ethane, n value is how much here? 30 equals to 15 into 2. N value of ethane is 2. Here also have a look. N value of ethane is 2 only. In order to get the molecular formula equals to 2 into CH3. Yes, similarly for the mass, the value of n is same, that is 2 only. Okay, so molecular mass equals to n into empirical mass. So molecular mass divided by empirical mass. Also we got n, the same integer. Okay, so these two, have a look. Okay, so molecular formula by empirical formula equals to n. Another relation we got, molecular mass divided by empirical formula mass also equals to n, that is an integer. Okay, then another relationship, another relation we have got out here is that we already have done. You know that molecular mass would be twice of its vapor density. Okay, we've done in class 10. Molecular mass, remember, is twice of vapor density, can be written as Vd. Okay, now next we'll learn how to find out the empirical formula, okay, for a compound when the mass percentage of different elements are given. Okay, so we have got a numerical here. We have got a set of rules to find out the empirical formula. Okay, so we'll just see the rules. Okay, so the numerical here, the question is, a compound is there, okay, and it is composed of carbon, hydrogen, and chlorine. Okay, a compound composed of carbon, hydrogen, and chlorine. So the compound consists of carbon, hydrogen, and chlorine. Okay, and their mass percentage is given. Mass percentage of carbon is given, this much, and chlorine is given. Okay, so that's the question. Then you're also given the vapor density of the compound. Vapor density of the compound is given 59.75. Determine its molecular formula. Okay, you have to find out the molecular formula. Okay, first thing, what we'll learn out here is to find out the empirical formula when mass percentage of the components are given. Okay, look till here only. Okay, just forget about this one now. So the question we are given is, we have got a compound which consists of 3 elements. Okay, carbon, hydrogen, and chlorine. Okay, and their mass percentage of carbon and chlorine is given. Carbon and chlorine is given. Now you have to find out what empirical formula. Okay, we have to calculate this. Now let's see how we can find out. So first thing, mass percent of carbon is given. It is 10.04%. Okay, that you'll write. Then you are given next of chlorine. Okay, mass percent of chlorine is given, that is 89.12%. Okay. Now, in order to find the empirical formula, we need to know the mass percent of all the elements, carbon, hydrogen, and chlorine present in that compound. Okay, we are given for carbon and chlorine. We are not given for the third one, that is hydrogen. Okay, we need to find out by ourselves. We can easily find out how, because you know very well, mass percent means out of 100. Yes, if carbon and chlorine are given, you can easily find out the third one would be 100 minus this plus this. Okay, so mass percent of hydrogen is 100 minus 89.12 plus 10.04. Okay, that would be equal to 89.12 plus 10.04 equals this much, minus 100 would be equal to 0.84%. Okay, so we got the mass percent of all the elements, carbon, hydrogen, and chlorine. Okay, now to find out the empirical formula, we have got some steps. Okay, let's see. Okay, we'll draw a table kind of thing. First one, we'll write the element, then we'll write its symbol, then we'll write its mass percent. Okay, then we'll write its atomic mass. Okay, so the first element, let's write carbon. First element is carbon, and what is the symbol for carbon? C. Mass percentage is 10.04. Okay, atomic mass of carbon is 12. Okay, next, now we'll find out number of moles. How do we find out number of moles? Given weight, that is the mass percent divided by atomic mass. Okay, atomic mass. Out here, .04 divided by 12. Okay, 10.04 divided by 12 will give us 0.8366. Okay, up to 2 decimal places, 0.84 I can write. Okay, so we got this much. Then another one is carbon, we already did. Now next one is hydrogen. Okay, so similarly we do the same thing for hydrogen. Hydrogen symbol is H. Mass percent of hydrogen is 0.84, 0.84. Okay. Don't have a ruler. Okay, so that is it. Then atomic mass of hydrogen, you know, it is 1. So out here, number of moles would be mass percent, that is 0.84 divided by the atomic mass, that is 1. Okay, so we'll get out here 0.84. Then finally for chlorine, you know, chlorine, the symbol is Cl. The mass percent we have got out here is 89.12, okay, percent, and atomic mass of chlorine is 35.5. Okay, percent, you need that right, 35.5. Now let's find out the number of moles. Number of moles out here would be, given weight is 89.12 divided by 35.5. Okay, so 89.12 divided by 35.5 would be equal to 2.510. That would be equal to 2.51. Okay, so we got 3 numbers out here. Number of moles here for carbon is 0.84, for hydrogen is 0.84, then for chlorine is 2.51. Okay, then in the next column, what we're going to do is we are going to find out the simplest molar ratio. Okay, now how we are going to find simplest molar ratio is, now we have got number of moles for carbon is this much, for hydrogen is this much, and chlorine is 2.51. Out of these 3, we are going to find out the lowest one, okay, the smallest one. Which is the smallest one? Okay, these 2 are same, the value is smallest out here, 0.84. Okay, now with the smallest number, we are going to divide all of these 3. For carbon, we have got 0.84 divided by the smallest number out here is the same one, 0.84. Okay, and how much we get out here? 1. For hydrogen, for hydrogen we have got 0.84 divided by the smallest number, that is 0.84. Again out here 1. Then finally for chlorine, it is 2.51 divided by the smallest number, that is 0.84. Okay, so let's divide that. 2.51 divided by 0.84 would give us, the value is 2.988. Okay, we can round it up as 2.98, we can write it as 3. Okay, so we got out here for carbon, the number ratio is 1. For hydrogen it is 1, then for chlorine it is 3. Okay, so our empirical formula equals to carbon, hydrogen, and chlorine. Carbon is how many? 1. So 1. Hydrogen 1. Chlorine it is 3. So our empirical formula is CHCl3. Okay, so this is the empirical formula of the compound. Okay, so these are the rules that we need to follow. These are the steps you need to remember. If you are given the mass percent, you can easily find out the empirical formula like this. Okay, now our question was, okay, so from here, a compound composed of this, the mass is given. We already found out the empirical formula. Now the second part of the question is, the vapor density of the compound is given. Okay, fine, we know the vapor density. We have to find out the molecular formula. Okay, now we are going to find out the molecular formula. We found out the empirical formula, fine and good. Okay, so you know that molecular formula is equals to n integer, some integer, into empirical formula. Okay, so empirical formula we already found out, it was CHCl3. We need to find out the molecular formula, but in order to find out the molecular formula we need to find out the integer n. We do not know the integer n, yes or no? Okay, so how we can find out is, what we are given is vapor density. Okay, from vapor density we can easily find out the molecular weight. Yes, so we'll use that. Okay, so we need to find out n. There's another way of finding n. What is another way of finding n? You know, molecular weight is equals to n into empirical weight. Okay, so n will find out this way. Okay, molecular weight equals to n into empirical weight. Molecular weight equals to 2 into vapor density. In the question, vapor density is given, so from there we can find out the molecular weight, which is 2 into 59.75. 2 into 59.75, 119.5. Okay, this is our molecular weight. Now empirical weight also we can find out. How? Because we are given the empirical formula, CHCl3. We found out just now, no? So from there we'll find out the empirical weight. Carbon is how much? 12, plus hydrogen is 1, chlorine is 35.5 into 3. That would be equal to 12 plus 1, 13, plus 35.5 would be into 3 would be equal to 106.5. okay, plus 13 would be equal to 119.5. so we got molecular weight, empirical weight. So we'll put out here molecular weight divided by empirical weight would be equal to n. How much is molecular weight? 119.5 divided 119.5, value is same, so n value is 1. Okay, so now putting the value of n as 1, we can easily find out the molecular formula. So molecular formula equals to 1 into CHCl3 equals to CHCl3. So for this question, okay, we have got the molecular formula and the empirical formula same, CHCl3. Okay, so for other compounds you may get n value 2, 3, 4 like that. Okay, so that is how we solve the question. Then what you will do is, you have got many questions out here you're given in the book. Okay, on page number 34, 35 and all, you go through it. Okay, try to solve. Then you can do this one by yourself. 39, you can try this. 39, composition sodium phosphate also you can, yeah, these two you can try on your own. Now next, let's see calculations based on chemical equations, okay, which is called stoichiometry. So basically here you'll be given a chemical reaction, okay, and you have to find out the chemical equation for it, then balance the chemical equation. So basically you'll find out the balanced chemical equation, and in the question you'll be given the mass of one of the component. Okay, like for example, suppose this is the chemical reaction and you'll be given the mass of this one, SiF4. You have to find out the mass of the other. Say for example, what is the mass of SiO2, or what is the mass of HF. Okay, or sometimes you'll be given the volume, okay, and you have to find out the mass for the other. Suppose for example, let's take you are given the volume of HF. You have to find out the mass of SiF4, mass of SiO2. Okay, or sometimes you can be given the volume of one component. You have to find out the volume of the other. Okay, so there will be question relating mass. Mass will be given, one component of will be given, and mass of other you have to find out. There will be sometimes mass volume relating questions. Okay, mass will be given, volume you have to find out, or volume relating questions. Volume will be given, volume of the other you have to find out. Okay, so let's try to understand this, and also you have done this in class 10. Okay, let's take one example. The first one, the chief component of glass is silica. Okay, so the question is, chief component of glass is this compound silica, SiO2. It can be dissolved by hydrofluoric acid, HF, according to the following reaction that produces silicon tetrafluoride. It produces silicon tetrafluoride at a room temperature. And okay, fine, you are given the equation, chemical equation, and also it is balanced. Okay, so you're given the chemical equation, SiO2 plus 4HF is producing SiF4 and water. Okay, now the question you are asked is, how many grams and how many moles of SiF4 can be produced from 63.4 grams of HF? So the question is, how many grams of SiF4? Where is SiF4? This is, okay, you're asked to find out the how many grams means weight or mass. Weight or mass is same in chemistry, I told you, no? So mass of SiF4 you have to find out, and what you are given, mass of HF. Mass of HF is 63.4 grams. You are given. You have to find out the mass in the first case, then later you have to find out the moles. So you see, you are given the mass of one component, HF. You have to find out the mass of the other component. Okay, now how you're going to solve is, have a look. So we have got the chemical reaction, SiO2 plus 4HF is giving you SiF4 and 2H2O. Okay, so this is the equation. Weight of SiF4, you have to find out weight of HF is given. So from the equation, you'll try to find out the mass of 4HF and SiF4. Okay, from the equation we have got 4HF. So molecular mass of this one, hydrogen fluoride, from the equation is 4 into hydrogen, it is 1. Okay, and fluorine atomic weight is, okay, 19 here. Okay, it can be given in the question, or you have to know by yourself. Okay, you have to memorize the atomic weights. Okay, but basically most of the time it will be given in the question. If it's not given, you have to write by yourself. So we have got HF 1 plus 19, that would be equals to 4 into 19, 20, 4 2s are 80. Okay, 80 grams. Then SiF4 silicon, it is what is the, okay, 28.1. Okay, Si is 28.1 plus fluorine is 19 into 4. Okay, that would be equal to, okay, 19 into 4 plus 28.1 would be equal to 104.1. Okay, 104.1. Okay, grams. So from the equation we got that 80 grams of HF would give you 104.1 grams of SiF4. Okay, now here what we have to find out is SiF4, weight of SiF4. So SiF4 I will write on the right hand side. Okay, so from the equation we got 80 grams of HF produces 104.1 gram of SiF4. Okay, then unitary method we can use. 1 gram of HF will give you how much? 104.1 divided by 80. Okay, grams of SiF4, Then for how much we have to find out? 63.4 grams. So 63.4 grams of HF will give you 104.1 divided by 80 into 63.4. Okay, 104 divided by 80 into 63.4. That would be equal to 82.49925 grams. Okay, that would be equal to 82 point, we can write it 5 grams. Okay, so this is the answer that we got. Then next one, you have to find out how many moles of SiF4. We got the weight. Okay, from the weight we can find out the number of moles of SiF4. So next, number of moles of SiF4 would be equal to number of moles. We can put the formula relation that we got earlier, given weight by molecular weight. Given weight is how much? Weight is 82.5 divided molecular weight. Molecular weight SiF4, same thing out here. Molecular weight is 104.1. 104.1, that would be equal to 82.5 divided by 104.1. That would be equal to 0.7925 moles. Okay, or you can do this in another way. Okay, or from the equation, okay, I'll show you. The equation is SiO2 plus 4HF giving you SiF4 plus 2H2O. Okay, so the question is this one. Then you are given 63.4 grams of HF. HF is 63.4 grams of HF. You have to find out how many moles. Okay, how many moles of SiF4. Okay, so from the equation you can see 4 moles of HF will give you 1 mole. Okay, so this 63.4 grams will give you how many moles? What you'll do is, first 63.4 grams, you'll convert it into moles. Okay, out here 63.4 grams of HF equals to how many moles? Given weight, you are finding number of moles for this one, 63.4. Given weight by molecular weight. Molecular weight. Given weight is how much? 63.4. Molecular weight of HF is how much? 63.4. HF is, hydrogen is 1 plus fluorine is 1920. 0.4 divided by 20. So 63.4 divided by 20 is equals to 3.17 moles. Okay, now you got out here 3.17 moles. Okay, from the equation what we have got is, from the equation 4 moles of HF is giving you 1 mole. 4 mole means, have a look, the coefficient out here, 4 HF is there, no? So 4 moles. 1 SiF4 is there, so 1 mole of SiF4. Okay, so 4 moles, then 1 mole of HF will give you 1 divided by 4 moles of SF. Then how many moles we have got? 3.17. So 3.17 moles of HF would give you 1 by 4 into 3.17. So 3.17 divided by 4 would give you 0.7925 moles. Same. Okay, we got the same number. Okay, so this way also you can do from the equation, or this way also you can do, your choice. Okay, so that is how we find out. Now the next question we have taken is, how many grams of sulfuric acid is required to produce 20 grams of hydrogen? Okay, so the question is, how many grams? Weight is asked. Grams means weight of sulfuric acid. Sulfuric acid, you know it, the formula is H2SO4. Is required to produce 20 grams of hydrogen. Okay, so we have to find out the weight of H2SO4 that produces 20 grams of hydrogen H2. Okay, we are not given the equation here. Okay, so we have to find out the equation by ourselves. You know that acid will give out hydrogen when they react with some active metal. Okay, so some active metal reacts with acid to give you hydrogen. We have to form the chemical equation. Okay, so the active metals would be zinc, Zn, iron and all. They react with sulfuric acid to give you hydrogen. So let's write the reaction. So let's take the active metal zinc. Okay, zinc, Zn, reacts with sulfuric acid H2SO4. Okay, gives hydrogen H2. Okay, and the other component formed, other product form is hydrogen is gone. What is the other product form? It's ZnSO4, the salt. Yes, ZnSO4, zinc sulfate. Okay, after writing the reaction, you need to see whether it's balanced or not. Okay, if it's not balanced, you have to balance it. Like for example, zinc. Okay, here zinc, fine. H2, sulfate, sulfur, oxygen. This is balanced. Okay, so now let's try to solve it. You have to find out the weight of sulfuric acid. Weight of this one you have to find out. Okay, and what you're given H2 20 grams. This is 20 grams weight, and weight of this one we have to find out. Okay, so from the equation, let's see the weight of H2SO4 is hydrogen. It is 2 into 1 plus 32 plus 16 into 4. So we get that as into 4 plus 16 into 4 plus 32 plus 2, 98. Okay, so 98 grams. From here, hydrogen 2 into 1, 2 grams. Okay, so from the equation we got 98 is giving you 2 grams of H2. Okay, so let's use this information to find out the weight of H2SO4. Now, we have to find out the weight of H2SO4. So what we're gonna do is, the H2SO4 portion, we'll keep it on the right hand side. So how we'll write is, from the equation, we know that 2 grams of H2 gives, is produced from 98 grams of H2SO4. Yes, 1 gram of H2 is produced from 98 divided by 2, unitary method. Yes, then for how much you have to find out? 20 grams will have 98 divided by 2 into 20. That would be equal to 98 into 20 divided by 2. Answer is 980 grams of H2SO4. Okay, so this is how you find out. Next, let's see another question. 5 grams of impure sample of common salt. Okay, 5 grams, which is impure sample of common salt. Common salt, you know the formula is NaCl. Okay, on treatment with excess of AgNO3 solution gives you 9.812 grams of AgCl. What is the percentage purity of that sample? Of that sample means common salt. Okay, so it is asking you the percentage impurity of that sample. Okay, and here you are given 5 grams of impure sample is given. Okay, so first thing what we are going to find out is, what is the pure amount of NaCl? impure amount is given 5 grams. You have to find out pure amount. Then only you can find out the percentage impurity. Okay, so they have given the equation, not the equation, the reaction. They have told common salt reacts with AgNO3, giving you AgCl. Okay, so your task is to find out the chemical equation. Okay, so let's try to write the chemical equation. NaCl reacts with AgNO3, NaCl plus AgNO3, giving you AgCl. Till here it's given AgCl. Okay, then from the equation you have to figure it out. If one of the component is AgCl, then the other would be NaNO3. So you'll write the chemical reaction. Okay, then you'll try to balance it. See, it's already balanced, so there's no need to balance it. Okay, if it's not balanced with the reaction, then you will balance it. So we got the required balance equation. Okay, so again, let's back to the question. 5 grams of NaCl, which is impure, is given. And it gives you 9.812 grams of AgCl. Okay, so you are given AgCl weight is given 9.812 and NaCl given, but it is impure amount. 5 gram is impure amount. So what we have to find out is the pure amount of NaCl. Weight of AgCl is 9.812. You have to find out the weight of NaCl. Okay, so let's relate it. So from the equation, you find out the molecular weight here, molecular mass. Okay, 1 mole is given, 58.5 grams. Then 1 mole of AgCl, atomic weight of Ag is 108, chlorine is 35.5, 143 grams. So from the equation, we saw that NaCl is 58.5, Cl is 143.5. Okay, so which one we have to find out? Weight of NaCl. So weight of NaCl, we are going to keep it on the right hand side. So from the equation, 143 grams of AgCl gives you this much. Okay, 1 gram will give you this divided by this number. Then for how much we have to find out? 9.812. 9.812 will give you 558. This divide into 9.812. That would be equal to this number, 4 grams. So what we got out here is 4 grams is the weight of pure NaCl. Impure sample was 5 grams. So how much is the impurity? 5 minus 4 grams. Impurity we got 1 grams. Okay, now the question it is asking, what is the percentage impurity? Okay, now the formula to find out the percentage impurity would be whatever is the impure amount, you'll write divided by the total amount into 100. That would be the percentage purity. Okay, so what is the impure amount? You got 1 divided by, what was the total amount? 5 grams. So 1 divided by 5 into 100 equals to 20%. Okay, so we got the percentage impurity. Okay, I have done extra out here, extra work. Percentage purity also I have found out. Then percentage purity would be pure amount divided by total, similar to this one. Okay, into 100. What is the pure amount? 4 grams. So 4 grams divided by total was 5 into 100, that is 80%. That is the percentage purity. Okay, let's see another question. We have got how much potassium chlorate is needed to get enough oxygen for completely burning 84 liters of carbon monoxide. Okay, so you have to find out the weight of potassium chloride which is required to get oxygen that burns 84 liters of carbon monoxide. You should know that KClO3 is the formula of potassium chlorate. It will decompose, it will give you oxygen. Okay, and in addition with oxygen, it will decompose to form KCl and oxygen. So KClO3 decomposes to give you KCl and oxygen. This is not balanced equation, so balance it here. KK1, chlorine 1, oxygen is 3, oxygen is 2. So we need to multiply it with 2, here with 3. So we've got 2K. So here also we need to make it 2. 2K, 2Cl, 3 2s are 6. This is balanced. Okay, then the next part is oxygen for completely burning 84 liters of carbon monoxide. Carbon monoxide, when it burns in oxygen, the product formed is carbon dioxide. Okay, let's balance this equation. Carbon 1, oxygen is CO is there. Carbon monoxide is CO. Oxygen is 2 plus 1, 3. It is 2. So let's make it 2 first here, then 2 carbon, 2 plus 2 4, 2 2s are 4. These are the two equations. Okay, now the question is, you have to find out the weight of KClO3 that gives you enough oxygen, this oxygen, okay, which will burn 84 liters. So 84 liters of CO is given, okay, and you have to find out that weight of KClO3 which will give you enough oxygen to burn 84 liters of CO. So what you'll do is, first from this reaction you'll find out the amount of O2, okay, or you can find out the volume of O2, okay. Then from when you get the volume of O2 you'll find out, okay, the weight of KClO3. Okay, so that is how you do it. Okay, so out here now have a look. 2 CO plus O2 is giving you 2 CO2. Okay, now you are given 84 liters. Okay, so we have got the equation 2 CO plus O2 giving you 2 CO2. Okay, you're given out here 84 liters. You have to find out the volume of O2. Okay, so you see out here 2 moles reacts with 1 mole of O2, or you can also write 2 volume of CO reacts with 1 volume of O2. Okay, 2 volume reacts with 1 volume. 1 is the coefficient out here, or you can write it as 2 liters react with 1 liters. Okay, so from the equation you got 2 liter, we have to find out this, no? So 2 liter reacts with 1 liter of oxygen. From 1 liter you get half liter of oxygen. Then for how much you have to find out? 84. So 84 liters give you 42 liters of oxygen. Okay, so that we got. Now we have to find out the weight of KClO3. Okay, so what we found out from the first equation, 44 liters of oxygen. 42 liters. This is what? Volume. Okay, you are given volume, you have to find out mass. Okay, so this question is relating volume and mass. Okay, so volume is this much amount is given, you have to find out the mass. So 2 KClO3, let's find out the mass for this one. It is 245 grams. Okay, then volume from the equation, let's find out. Out here is how many moles of oxygen? 3 moles. From the moles, can you find out the volume? Yes, of course. You know that 1 mole at STP always contain 22.4 liters. So 3 moles will contain 67.2 liters. Okay, so from the equation we got 67.2 liters will give you this amount of KClO3. Okay, so from there, can we find out the weight of KClO3? Yes. Okay, so we are finding this, so we'll put it on the right hand side. So we get 67.2. okay, from here you know how to do it. Okay, and there are more examples in the book. Please go through the solved questions given in the book. Okay, numerical questions.